Read and write to text files from Web API endpoints. Create an ASP.NET Web API project. We're using .NET 9 for this demonstration with the standard settings. Ensure that Use Controllers is ticked. If you want to, you can delete all the weather example stuff from the template. Then add a data folder and a normal text file. This can also be a JSON file or CSV file. It doesn't matter because it's all text anyways. In our example, we called it datafile.txt. What's important to remember is to right-click this file and change its properties. Set its build action as content and its copy to output directory to either copy always or copy if newer. Now, in our appsettings.json file, we need to set a path to this file. You'll notice we're setting a relative path here. It doesn't matter what you call the key, we just named it file access path. Next, we need to create the services that will read and write to our file. We added a services folder and a class called File Access Services. We'll inject that file path into it, and of course, it needs to inherit from an interface class by the same name. The first method in our service will read all the text from this file. First, it checks if the file doesn't exist. It throws a file not found exception with a message showing us the file path. Otherwise, it reads all the text from the file and returns it as a string. The write file method takes a content string argument to write to the file. Like the read method, it also checks if the file path is correct before writing the content to the file. Then we added the File Access Services interface class with the two methods signatures. We need to register this service in our program.cs file. Before we do that, we need to get our relative path from the app settings file and change it to an actual file path. For this, we'll need the builder environment. We get the relative path from our settings, then combine that with the content root path of our environment. Now we can register our service and inject the file path into it. With all that in place, we can go create our controller. Right-click the Controllers folder and select Add Controller. Here it's important to select the correct empty API controller template. Sometimes it tends to default to the MVC API controller. Just ensure to select the normal API controller. We called our controller File Access Controller, and because our services are registered, we can inject it into our controller. Our first endpoint is a HTTP GET method, and we simply called it read. The method itself will try to call the services read file method and return the content. Otherwise, if a file not found exception is thrown, it will return a not found status through the iAction result. The second endpoint is a HTTP post method called write. Now, if you're using validate anti-forge token here, we're going to disable it for testing purposes. You need a valid token from the front end for this to work. But since we're going to test this with an API tester like Scalar, we don't have a valid token yet. Our write endpoint will get the content it needs to write to the file from the string query passed to it. It will try to call the service's write file method, giving it the content. Again, if a file not found exception is thrown, it will return a not found status through the iAction result. Right, let's go test our API. We'll be using Scalar, so right-click your project and go to Manage New Get Packages. Browse for Scalar and install the Scalar ASP.NET Core package. Go to your program.cs file and map a reference to Scalar in the isDevelopment block. Now run your project, and on the host information page, control-click the top URL. This will open your browser, which will obviously tell you there's no page at this URL. Change the URL to include /scalar/v1. This will redirect you to the Scalar page, which shows our controller and its two endpoints, read and write. Since our text file is empty, let's go try posting some stuff to it first. Select the post endpoint and click Test Request. Our write endpoint requires some content passed to it, so we add some value for the content argument. Then click Send. We get back a 200 OK status and the message file written successfully. Great. close this test request window. Let's see if there's anything in the file. Select the Get Endpoint and click its test request. We don't need to pass any arguments to the read endpoint, so just click Send. It returns a 200 OK status and the content of our text file. Just to make sure this actually worked, open the text file in the project to see if it contains the stuff we posted to it. That's all fine and good, but what happens if multiple users calls the endpoint to write to the same text file? This most certainly will generate concurrency issues. There are two ways to solve this, depending if you have low or high volume processes. But first, we need to make our methods asynchronous. In our file access services, change the read and write methods to be asynchronous. We'll call the asynchronous versions of read all and write all. Then, remember to update the signatures in the interface class. Now in our controller, we can make our endpoints asynchronous as well. The read endpoint will call the asynchronous version of the read file from the service, and the write endpoint calls the asynchronous version of the write file from the service. With that in place, we can now implement a semaphore for writing to the text file. Back in our file access services, we'll implement a semaphore to prevent multiple writes to our text file. The old school method was to put a lock on the file, but that doesn't lend itself well to modern asynchronous programming. Think of a semaphore as a security guard at a queue. In this case, we only allow one write task to pass at a time. The other write tasks will have to wait their turn when the semaphore becomes available again. This is why the semaphore is static. It needs to keep track of all the write tasks still waiting in line. So in our write method, we first wait to see if a position in the semaphore is available. Once it opens, we can write to the text file and finally release the semaphore for the next write task. This works great for low-volume writes by multiple users. For high-volume queues, it's better to use a dedicated queue service, which handles the write tasks in the background. We'll add a new class to our services folder and name it File Write Queue Service. This will use a dedicated channel that holds all the strings to be written to the file. In its constructor, we set our file path and start running the process. So as soon as this service is created, it will begin processing whatever is in its queue. The onQueue method is used to add strings to the queue. We add an interface for this service with the one method we'll be using and register the service in our program.cs file. In the controller, we inject the additional write queue service and added a new endpoint. This post request will use the queue service to write to our text file. While you could set up complex performance tests for these endpoints, at least for now, we can go test if the endpoints actually work. In Scalar, we see our newly added endpoints. Let's do the post requests first. The first write that uses the semaphore seems to be working, and the queue_write endpoint seems to be working. Let's do a get and see what's in the file. And that's how you can implement semaphores and channels. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.